Imagine the exact moment it happened. Not a campfire, not a hearth the first time. A lightning strike ignites dry grass on the open savanna. A hominin, maybe 1.5 million years ago, sits at the edge of the burning zone and stays close longer than instinct says to. The warmth is overwhelming. In the weeks after, the same individual or someone nearby approaches the cooling ash and finds something: cooked tubers, exposed by the fire, softened, sweetened, transformed. They eat one, then another. The caloric yield per gram is higher. The digestibility is higher. The toxins in the raw form have been partially neutralized by heat. And something in the jaw, over the next 1,000 generations, begins to change. The teeth get smaller, the gut gets shorter. The skull gets rounder because a shorter gut means less structural support needed for the digestive apparatus, and less structural support means the skull can expand. A bigger skull means more brain. More brain means more fire. Now, ask the question the other way. What if that first encounter never happened? What if the hominin on the savanna 1.5 million years ago walked away from the burning grass and the cooked tubers went uneaten? The answer is not just that we would have fewer tools and no cooking. The answer is that we would not be us. We would be a different species, with a different body, a different brain, and almost certainly no civilization of any kind to wonder about any of this. The answer isn't one thing. It runs through gut length, skull morphology, parasite load, social bonding, and sleep architecture. Each layer removes something you take for granted. Let's go. Start with what fire actually did to the human body, because this is where the thought experiment immediately goes somewhere most people don't expect. Richard Wrangham at Harvard University published the cooking hypothesis in Catching Fire in 2009, synthesizing decades of paleoanthropological and nutritional research. His core argument: cooking food was not a convenience that followed the evolution of big brains. Cooking food drove the evolution of big brains. The evidence runs through comparative anatomy. Homo erectus, appearing in the fossil record around 1.8 million years ago, shows a dramatic and sudden change from earlier hominins. A 30% reduction in tooth size, a significant reduction in jaw muscle mass, a reduction in gut size inferred from the narrowing of the rib cage, and a 25% increase in cranial capacity. All of these changes move in the same direction at roughly the same time. Wrangham's explanation: they were caused by the adoption of cooking. Raw food requires longer digestion, more gut tissue, more metabolic energy allocated to processing. Cooked food delivers more calories per gram, requires less gut to process, and frees metabolic energy for brain growth. The human gut is approximately 60% smaller than expected for a primate of our body size. That missing gut tissue represents metabolic capacity redirected to the brain. Without cooking, the brain cannot be this large. Without this brain, civilization does not happen. Without fire, you do not get cooking. Remove the fire, and the chain collapses at its base. Here's where it gets strange. The body consequences run deeper than brain size alone. Leslie Aiello at the Wenner-Gren Foundation and Peter Wheeler at Liverpool John Moores University published the expensive tissue hypothesis in Current Anthropology in 1995, arguing that brain tissue and gut tissue compete for metabolic resources in a fixed energy budget. Growing one requires shrinking the other. Cooking resolved this competition by making the gut's job easier, allowing it to shrink, freeing metabolic budget for neural expansion. But the implication for the counterfactual is stark. Without fire, the human brain is constrained by the metabolic demands of a full-sized primate gut. The maximum brain size achievable in a raw food hominid, based on comparative primate data, is significantly smaller than what we have. How much smaller? Hard to say precisely. But every great ape that has ever lived with a full-sized gut-processing raw food has a brain between 300 and 500 cubic centimeters. The modern human brain averages 1,350 cubic centimeters. The gap is not bridgeable by intelligence alone. It required a dietary transformation so profound it restructured the body from the jaw to the skull. No fire means no cooking. No cooking means a gut that cannot shrink. A gut that cannot shrink means a brain that cannot expand to this size. The species that never discovers fire is not a primitive human. It is a different animal. Now, let's tackle what fire did to time. Specifically, nighttime. Before controlled fire, hominins in open environments had no reliable defense against nocturnal predators. Like every other primate, they would have needed to be in trees or some form of shelter before dark, and they would have needed to be quiet, hidden, and inactive throughout the night. Fire on the ground changes this completely. David Sampson at the University of Toronto published research in 2021 analyzing sleep patterns across primates and found that humans sleep significantly less total time than other apes, averaging 7 hours versus 9 to 10 for chimpanzees, but spend dramatically more time in REM sleep, the stage associated with memory consolidation, emotional processing, and creative problem solving. Sampson's hypothesis: ground sleeping around fire allowed hominins to sleep in shorter, safer bursts without the need to maintain a precarious tree sleeping posture, and the increased security allowed deeper, higher quality sleep stages. Fire didn't just warm the night, it restructured sleep architecture across the species. Without fire, hominins sleeping in trees sleep like chimpanzees more total hours, less REM, less consolidation of complex learning, less capacity to build on the previous day's cognitive work. The cognitive compounding that produces tool refinement, language development, and cumulative cultural knowledge requires the kind of sleep fire made possible. No fire means different sleep. Different sleep means slower cognitive accumulation. Slower cognitive accumulation means the gap between one generation's knowledge and the next never closes fast enough to produce civilization. Here's something else that almost never comes up: parasite load. Raw meat, consumed without cooking, carries pathogen levels that are frequently lethal: Toxoplasma, Trichinella, Salmonella, Campylobacter, E. coli, O157. In a raw food hominid population, chronic parasitic infection and periodic acute food poisoning would have been the baseline condition. Phyllis Lee at the University of Stirling and colleagues analyzing parasite-driven mortality in non-human primate populations found that gastrointestinal parasites and food-borne pathogens are among the leading causes of mortality in wild primate groups, particularly in infants. Cooking kills parasites. It reduces pathogen load so dramatically that the adoption of cooked food is likely to have reduced child mortality substantially in early hominin populations, increasing the proportion of individuals who survive to reproductive age, and allowing population growth rates that could sustain the larger, more complex social groups that language and culture require. Without fire, the raw food population is smaller, sicker, with higher infant mortality, lower average lifespan, and less bandwidth for cultural transmission across generations. The grandmother who passes knowledge to grandchildren only exists if she survives long enough to become a grandmother. Fire helped her survive. So, here's the part nobody tells you. The question of what humans would be without fire is really a question about which features of being human are optional and which are load-bearing. And the answer from biology is uncomfortable. Almost everything that makes us recognizably human is downstream of fire. Language, which requires a brain large enough to support it. Abstract thought, which requires sleep deep enough to consolidate it. Dense social groups, which require cooked food shared around a hearth as the original bonding mechanism. Anthropologist Polly Weisner at the University of Utah analyzed the content of conversations in firelight among the Jew, Hoansi of the Kalahari, and published in PNAS in 2014. The finding that daytime conversations are dominated by practical coordination, food, logistics, disputes. Nighttime firelight conversations are dominated by storytelling, social bonding, myth-making, and the transmission of cultural knowledge. Fire created the context. The context created the stories. The stories created the culture. Remove the fire, and you don't just remove the warmth and the cooked food. You remove the gathering point. You remove the dark hours made safe enough for imagination. You remove the original school. The hominin on the savanna sits at the edge of the burning zone. The rational response is to leave. Every instinct says to leave. Something keeps her there. The warmth is overwhelming. The world is changing in a radius of 30 meters around a burning piece of grass on an African plain. She doesn't know that she is at the hinge point of her species. She doesn't know that the cooked tuber she will find in the cooling ash will start a cascade that ends, 1.5 million years later, in a creature that splits atoms, writes symphonies, and sends machines to other planets. She is just warm, for the first time, in a darkness that doesn't require hiding. That is enough. That is everything. That is all it took.